I think that we can go ahead and get started. I'm going to do a little bit of housekeeping announcements, and I'm going to introduce everybody to today's speaker. But for those who are just joining, we have a short poll that's going. I'll leave that up for a while, so there's no rush filling it out, but it does help us kind of make sure that we're creating content that it feels relevant and interesting. So thank you all. And if you filled out the poll already, I would love for people to drop into the chat where they are joining from. I'm in a slightly unusual place compared to usual. I'm actually at the beach this week on the Outer Banks. So I'm joining from a slightly unusual location, but I would love to hear where people in the world are joining us from. So if you want to drop that in the chat, I would love to see that. Let's kind of get started here. So in terms of housekeeping notes, the meeting is going to be recorded, and you'll get kind of an automated email, I think in 24 hours or in 48 hours, that will have a link to the on-demand video so you can watch it. You'll also get a copy of the slides. If you have questions, there's a few ways that you can ask questions. You can either use the chat. I see people have figured out how to get the chat to work. So we've got people from Nova Scotia and Nashville and Chicago, Argentina, the Outer Banks, which is where I am, South Carolina, London. So wonderful to see people joining from all over the world, and France, bonjour. So you will get the meeting recording and slides, in the next 48 hours or so. So don't feel like you have to take too many notes. This is going to be a fairly technical tutorial, so it's going to be kind of an in-depth end-to-end example. Prima, who is our speaker today, actually will also be sharing a code repository that has a lot of the code, or potentially all of the code that she's going to show today. So also kind of stay tuned for that link so that you don't feel like you're copying any code or anything like that, since that will be hard to do. There's going to be a good amount of code. We will also have Q&A. You can use the chat here that you're using to put in your location. You can also use the Q&A function. If you'd rather be anonymous, that's fine too. So if you don't know me, my name is Rebecca. I've been a data scientist 10 years. And I'm super excited to introduce you to Prima Roman, who also has been a data scientist for about 10 years or so. She and I have known each other a long, long time. And I am very excited to introduce you. But before I introduce Prima, potentially many of you have heard that the success rate for data science projects is extraordinarily low. And when I was kind of just getting started, I thought maybe I was doing something wrong, but I think that this is something we're all sort of experiencing, and maybe have been a little bit shy to talk about until recently. And I think, so I think it's good that we're starting to have these conversations in the light and really talking through some of the challenges here. But I suspect that percentage of kind of only 13% of data science projects make it to production is actually as high as it is because of the creative problem solving of engineers like our speaker today. So I'm so pleased to introduce you all to Prima Roman. She is a longtime open source contributor, and she is a distributed systems engineer at Rotational Labs. Her job is to make machine learning actually work in all sorts of kind of complex, distributed, bespoke, real world applications. So she is the one that you call in to get your model like across the last mile, doing things like containerization, refactoring, reimagining data science projects to make them more deployable, more memory efficient, less vulnerable to software supply chain exploits, of which there are increasingly many. If you've heard that metaphor about throwing your model over the wall, and I'm sure many of you recognize that as a pattern that you've observed at your own organizations. Well, Prima is the one on the other side of the wall who's catching those models and trying to figure out how to get them deployed for you. And so one thing that she's going to do today is she's going to sort of open a window in that wall so that you can see through to the other side. whether you're on the engineer side or whether you're on the data science side, she's going to kind of open a window and allow us to glimpse through and construct, you know, an end-to-end application using one of her current favorite design patterns, which is bootstrapping large language models using purely open source libraries. So I'm going to turn it over to you, Prima. I'm very excited. And you know, thank you so much for speaking with us today, and take it away.
All right. Thank you so much, Rebecca, for the nice introduction. And thank you all for joining today. I'm so glad to see all of you attending our webinar for today, talking about streaming NLP analytics made easy. So let's go ahead and get started. So what we'll cover today is we'll take a look at a business problem that requires an LLM. And as Rebecca mentioned, we'll see how we can bootstrap an LLM to start delivering results to our hypothetical customers. And then I will walk you through the steps to build a streaming sentiment analysis application. So it's not just building an LLM in your normal like batch-wise fashion. You can actually build a real-time sentiment analysis application. And it's going to be pretty straightforward. And you'll see a live demo of this application at the end. And what you'll get out of this webinar, at the end is you can see how it is possible for you to start incrementally delivering insights to your organization now without needing a trillion rows of data. And you can do this by just using open source tools. Like in this case, we'll specifically talk about Hugging Face and PyEnsign. And then we invite you to build your own LLM and share your work with us. All right, so why are we here? So we've all heard about LLMs, everyone's talking about it. People even outside of the data science community are talking about LLMs. And so I'm sure a lot of you have questions just like, I've had, which is, how can I build my own LLM? ChatGPT is a black box and it's something that I cannot customize. And others of you have, probably read that, these LLMs have been created using, trillions of rows of data, and your company does not have access to that kind of data. So how can you build one? And then others of you have dived into the code, behind LLMs and have probably gotten overwhelmed with like all of the math that's behind it, and they're kind of wondering, how do I even get started? Like this is all very complicated. Well, that's why we are here. And before kind of thinking about all of these things, what we really should do is take a step back and ask, what is the end goal that we're trying to achieve with the LLM? And so here, let me go ahead and present to you a use case. So imagine you are working in the customer success department at a large seafood chain restaurant, and what you're basically dealing with a lot of customer complaints, and it's taking you a long time to address them. Sometimes it takes you a week or even 2 weeks to deal with them, and some of these are very critical. There might be some complaints that need to be flagged for the legal department because you want to avoid lawsuits, and then also you don't want to have to suffer any kind of negative public opinion. And I'm sure a lot of you have heard that the restaurant business is a very tough business to be in. And if negative public opinion kind of festers for a long time, your business might get shut down. And certainly, like right now, let's imagine you're in this situation. You're only a few people in this department, but your restaurant serves 85 million customers every year, and you're drowning in this work. And you're even just addressing the complaints that are coming through email is like, it's just too much work, let alone like, those complaints that are coming through social media. And then you kind of, rack your brains and you kind of realize, hey, this is actually a great, problem for LLMs. You can basically see if you can try to use an LLM to analyze the social media posts, and then you can use sentiment analysis to bucket these posts into positive and negative reviews, and you can automatically triage them much faster. And so great, you know, that's actually a really good use case for LLMs. And here's what we'll kind of take a look at an architecture diagram of like what the solution would look like. So let's say you work with some of your colleagues and you look at like the social media posts that you have now, and you label them, you know, as positive or negative posts with these labels. So you have this label, and then we'll walk you through like, you know, basically how you would train this LLM model, but you'll have this application, you know, that trains on this data. And then you store this model, and then you store the, you know, model performance metrics in this model and metrics store. And then you can start to, you know, kind of like setting up an ingestion process to ingest social media posts, you know, as soon as a customer posts something on social media, you can create, you know, what's known as a publisher. So this is the notion of like, you know, how you can set up like a streaming, you know, application where, you know, you can take basically this data, ingest this data, publish this data, and then you have a subscriber on the other side, which is the scoring application, which is going to read in that data and generate predictions immediately. And then, you know, once you have the predictions, you know, based on like if the model predicted this review to be a negative review, it will get, you know, triage to the dispute resolution team. So it's basically will get routed there. And then positive reviews will get routed to the customer engagement team. And as you're kind of, you know, serving this model, you also want to be monitoring this model, you know, for its performance. So all of that, you know, gets, you know, routed to like a feedback mechanism, which is very important to have, because this is how you kind of learn over time how well the model is doing, and the feedback will kind of help you, you know, make improvements and changes and adapt over time. And that can kind of get fed back into this cycle again for retraining as needed. So this is, you know, pretty, you know, standard kind of, you know, solution that you would build with a machine learning model. And now you've kind of seen how it looks like in a streaming context. So that's great, except there's one thing. And as you know, those of you who might have attended our last webinar found out that 87% of data science projects never make it into production, which is a pretty shocking statistic. And I was actually pretty surprised to hear that. And, you know, so these are the struggles that probably a lot of you have experienced. And, you know, one of the things as someone who has worked on, you know, a few different machine learning projects over the years and having actually deployed models into production, you know, I wanted to share a few tips with you that you can take to, you know, ensure that this statistic goes down. And so with that, like the first tip that as I mentioned before, always keep the end goal in mind. And so here I want to kind of, you know, specifically talk about like taking that business use case with the seafood restaurant. So think about like what you're trying to do here. You're trying to actually reduce the workload for the customer success department. And, you know, oftentimes I think one of the things that a lot of people kind of think is that, you know, we need to have this model, you know, perform, you know, perfectly. Like it has to have scores, you know, accuracy scores in the 90% range in order to deploy it, you know, or else like it's just not good enough. But the reality is that even if you had models that are kind of performing in the 60%, you know, accuracy scores range, that's better than nothing. That in itself, like once the customer success department like gets these reviews and they're actually like, now you kind of streamline like what they're looking at. It helps, you know, their workflow, and then that you can kind of work with them, you know, over time to like make improvements on this model. And so really kind of, you know, thinking about like, you know, the end goal and thinking about like how you're solving this problem, you know, for your stakeholders, and realizing that you can actually provide value immediately, is something that you should be keeping in mind. And that kind of leads to the next tip, which is don't strive for perfection, iterate. So one of the things like, so my, you know, sort of like before I came into machine learning projects, I was in engineering projects. And one of the things that they, you know, software developer community have done is kind of migrate from, you know, waterfall methodology to agile, in the sense that, you know, rather than like building the whole application, because like by the time you build this like complex application, like customer requirements have changed, and then now they have to scrap all that work and start all over again. We switched over to an agile methodology where you start with an MVP, get the MVP going, and then get feedback from your stakeholders and customers, and then iterate over time. And through those iterations, you'll make, models and, machine learning applications, that will be a lot more resilient. And kind of along those lines, that leads to tip number 3, which is feedback loops are important. So as you're iterating on your solution, you want to make sure that you're, talking to all of your stakeholders and making sure that your application meets their needs. And you want to have, like earlier when I showed you the architecture diagram, having some kind of a feedback mechanism is crucial to ensure your project success. And then feedback kind of leads to the idea of communication. So, when we kind of like get kind of stuck in the code, you're kind of working, building this model. The reality is that this work is not going to be in a vacuum, right? Like you have to then hand off this model to like another team to kind of, it's going to be part of this larger application. And so in that case, you'll be working with a lot of different teams who don't necessarily see things in the same way, as you do, or they just have a different, different objectives, different, frame of mind, and trying to work with them to try to find ways to, understand each other and striving for a common goal. There's oftentimes some sort of friction that happens when you work with different departments that just don't quite see things the same way as you do, and striving for understanding is key here. And along those lines, also just lean into your engineering and platform teams, because like one of the things that unfortunately with a lot of data science, curriculums, like the focus has been on just the learning of like the statistics and the linear algebra and all those things, which are great, so they help you understand, how to build a model and how to improve it over time and how to tune it. But then, so that's like your first step. But then in order to like actually convert that to a deployable solution requires a different kind of mindset. So in this case, like for deployment, you kind of have to switch over to a somewhat of like an engineering hat in order to make sure that your models are resilient in a production environment. So some of the things that I've seen over time are like hard coding. So you're only like trained on this one data, like it works great, but then you haven't tried it on like other data sets to see like if it performs just as well, or there's not as much like configurable variables and things like there's like a lot of repetition that could have been easily replaced by like functions. And as somebody who's kind of come across it from the other side as a developer, I've actually had the opportunity to like work with a lot of really good data scientists to like hone in my machine learning skills. And on the flip side of it, like the data scientists that I worked with, were also, thankful, for me to kind of help them improve their programming skills. But the other benefit, that they got out of this is that they realize that even their workflows, are a lot more better because they figured out how to like so they were able to streamline, their work. And it made, and then this kind of helped us, deploy more models and deploy, and, we were a lot more efficient, with the, with our work. And so kind of really, leaning in and try to like add, kind of like add to your engineering chops is like definitely like the way to go. So I figured like we should spend some time on this. So hopefully, you got, some pointers and ideas that you can kind of take back, as you're working on your solutions. And so now let's actually look at how we can build a streaming, sentiment analysis application. So, one of the reasons like we selected Hugging Face is because it has a large selection of pre-trained models, including all the really popular ones that you've probably read about from Google, Microsoft, and Meta. And so you can really pick anything for your specific task. And then what you can do is basically take these pre-trained models and then feed your data to these pre-trained models, and use your kind of domain knowledge to kind of perfect it for your task. So I kind of, and the process is called transfer learning. And so the way I think about it is this. One of the reasons why LLMs are doing, are pretty successful is because, they've been trained on a lot of text, from around the internet. But then the kind of the rules of like language. So let's take, LLMs that are trained on like English text. Like the rules of grammar in English text is somewhat, finite. Like, there's like only a certain, order, and there's like grammatical rules that that occurs in the English language. So once you've learned on all of these like different patterns, like the models kind of can generate like very believable text. And so it's kind of like this like broad brush. But then when it actually take it for, apply it for your domain, what you really need to do is like convert this broad brush into a fine tip pen. And so it's kind of hone in on your specific like set of data, because like if you kind of imagine taking an example, like say if you had, our sports articles, versus like, articles about politics, you can kind of imagine like the word choices. All the combinations of words that occur in the sports articles versus articles on politics. So transfer learning kind of allows you to kind of then hone in on like on your data that's specific for your domain. So this is how you're able to like, you have no need for a trillion rows of data. You can just take something that was pre-trained on that data and then take it and fine tune it for your specific use case. And so in the spirit of the MVP, we'll take the architecture diagram we had before and pare it down to something that you can kind of immediately like write code with and like see it in action and then build it up over time. So for this application, what we're going to do is kind of simulating the idea of the positive versus negative reviews. I basically just took this Yelp data from Kaggle and took part of it and used it to train a Hugging Face trainer application. And we're going to use the Distilbert model from Hugging Face. And we'll build a sentiment classifier. And then we'll take the rest of like the data to kind of score the model on and generate predictions. And that will get fed to this Yelp review data publisher. And so this is where we'll use PyEnsign. And so the idea here is like we can actually sort of like simulate a real-time streaming solution by kind of just taking the data, and you can loop through the records. And so you can kind of see what it would kind of look like as if you were calling an API to get this data. And it's pretty simple. Like once you actually kind of see this working, then you can kind of take a real-time streaming source and just kind of change the code to like call an API and do the same thing. And so the idea here is that as you get, as you loop through the record, it's going to, the publisher is going to publish this data to a topic that we're going to call Yelp data. So for those of you who are not familiar with streaming solutions, the idea of a topic is sort of like a table in a relational database. And this is almost like sort of like inserting a record into a table, but in this case, we're kind of publishing this data to a topic. And then we have a scorer application, which is going to be the subscriber that's going to be listening to any new records that are coming into this topic and kind of act on it immediately to generate predictions. So you can kind of think about it as like a application that's querying this table, right? But instead of like having to do like run some manual query, this is actually going to be automated. Like as soon as like this new data arrives on this topic, the subscriber is going to go ahead and read that data and then generate predictions. All right, so before I get further into the actual code itself, I kind of wanted to see if there are any questions or about what I've discussed so far.
So there are a few questions here. So we have a question about transfer learning. So I think this might kind of go back to the slide, maybe one slide prior to this, where you had the kind of Hugging Face slide and kind of mentioned transfer learning. So the question is, does transfer learning require GPU? Does it require a certain kind of hardware? Or, because I've heard, we've heard that, a lot of these deep learning models do require custom hardware. Is that also true for transfer learning?
So I will say that it kind of depends on like how much data that you're training on, but like there's an application that we deployed that's actually like trained on a lot of data that did not require GPUs. In fact, so you'll see for this example, of course, it's a lot less data, but it was just like I was able to run it on my laptop and it's text data. And the more data you have, obviously, like you'll have to use some probably machines with like more hardware, but GPUs are not necessary, something you work up to. So I would say start with something that's a smaller data set, use and CPU you can run it on CPUs, and then as you have more data or there's something more specific with your data set, you might have to upgrade to GPUs. But I would not even think about GPUs to start with.
Got it. I don't see any other questions in the chat, but I did receive a question. Actually, I think you might have just answered it. Can this sort of stream approach you were talking about, the event-driven approach, can that be used for training as well as deployment? But it sounds like maybe that'll come up later in the slides.
So in this particular example, we're actually just training on the entire data frame. But I believe, I don't know about Hugging Face specifically, but there are other models where we can, those are like called online learning models, where we could actually even do, for training itself, we can also use a streaming solution. And you could actually technically, even if you have to, like in this case, for the Dilbert model, we're accumulating data before we train it, but you could, in theory, also stream the training data and then have some sort of a point where you have accumulated enough data and then train it on that data as well. So yeah, there's actually, so even if you have like a model that's like not an online learning model, you could still use a kind of like a streaming data source to like get new posts, and then you can have a training application that kind of accumulates this data and then train on that data set.
Thank you. So I actually did get a couple more questions. So let me know if you want to pause, and we can always, I'll keep track of these questions if we want to come back to them. But I think that this is a really, really good question. Basically, is there ever a use case for training an LLM from scratch? Like, if it's possible to go and find pre-trained models, easily in Hugging Face or other places, and if you can always do transfer learning on top of those models, is there even a need for doing any LLM training from scratch? And like, what would be different about that use case? So
you could train an LLM from scratch if you really need it to. I mean, it's just all like you have even before the thing that transfer learning allows you to do is like you already have the advantage of having these pre-trained models that have been trained on a lot of data from the internet. But you could technically, like with your own data set, also kind of like train your own neural network if that's all you kind of care about, like with your data set. So the models exist. It's just that if you kind of wanted to take advantage of these other models that have been trained on a wider variety of text, that's when you would use transfer learning. But there's nothing really kind of preventing you from like building your own. The only thing, you're kind of recognizing that you're training on a fewer samples, and you could potentially might need more data to improve your model performance.
Okay, Thank you. And for people who are throwing questions in the chat, just keep going. I'm going to let Prima go back to her content, but I'm going to keep track of all the questions that haven't been answered yet. And when we get to the next Q&A, I'll make sure that your question gets asked. So keep asking those questions, and we'll do another Q&A session soon.
Yeah, I mean, and these are great questions. But yeah, in the interest of time, I will kind of continue on so that you can kind of see some of the specific like code snippets. And as Rebecca mentioned, also like all of this, like we'll have the link to the GitHub repo as well, so you can take a look at the code and you can watch the recording later as well. So there's no need to like kind of be copying and pasting the code. So let's start with the trainer application. So the trainer application will use the Distilbert model from Hugging Face. And so the trainer, the components for this application will be the training arguments, which are basically a dictionary of like parameters that's going to be passed to the trainer class. And then the trainer class itself needs the following. So it'll need the pre-trained model, and it'll need the training arguments, and then a trained data set for training, and then an evaluation data set in order to evaluate the model performance. And then we need to pass in the tokenizer. So basically the tokenizer that was used to tokenize the train and test eval data set. And then it also needs a method to compute the metrics. So you're basically driving, before you train the model, there's going to be like metrics that you're interested in. And so you want to be passing that function to like calculate these metrics. And then you can basically then also tell the model which metric you care about the most. So it'll print out like all of these like different metrics, but then there's going to be like the one metric that for your particular use case that you want to optimize for, you be selecting that as well. All right. So the training arguments, as I mentioned, is like a dictionary, and there's like all of these parameters. There's actually a huge list of parameters if you did one of the looked at one of the examples on the Hugging Face site. But for the most part, like you can start with the defaults and then tune them as needed. And and then we also have basically there's going to be a training directory where we'll save the models after each run. And so this is pretty much like how you set up the training arguments, where you pass in these parameters, and then we'll also pass in like the directory where we want to save the models to. And then initializing the model and the tokenizer is pretty straightforward. So we're going to use the Distilbert tokenizer dot from pre-trained, and then here's the name of the model that we're using. And so essentially, like if you're going to use a different tokenizer and a different model, all you have to do is change this name. And then for the model, this is essentially a classification task. So you call this auto model for sequence classification dot from pre-trained, and then this is the name of the model. And then so we want to tokenize this data set before we feed it to the model. And so the way this works is the first thing we have to do, so we'll have a pandas data frame in this case, and we're going to convert it to a data set object, which is a Hugging Face class that has like with kind of its own way of like working with the data. And so that's pretty straightforward here. You just call train data set equals data set dot from pandas, pass in the train data frame, and then similarly for the test data set. And then we're going to, in order to do the tokenizing, we will basically apply this pre-process function. And then we set this batch equal to true so that this tokenizing happens in batches. And this pre-process function, as you can see, is just this one line, where we're using that tokenizer. And this instances is going to be the records that are in this data frame. And then we'll pull out the text from this data frame and set truncation equals to true and padding equals to max length. And so that will take what's text into and tokenize that text. And then similarly, we'll do the same exact same thing for the tokenized test. And then here's how we'll instantiate the trainer class. So all you have to do is called trainer equals trainer, pass in that model that we initialized earlier, the training args, and then the tokenized train, tokenized test, and then the tokenizer that we earlier. And then, so there's a function called generate metrics, which I'm not going to go over here, but it's kind of pretty much like setting up like your precision recall and F1 scores. And so you can take a look at that in the repo. And then all you have to do is called trainer.train. And then so what at each, there's at the end of like each pass, like you'll get a model that gets stored in the training, the directory. And then, after all of that's done, then it will evaluate to figure out like which one of those models is the best model. And it'll print out the metrics. So basically called, metrics equals trainer.evaluate. And then we can see like what the metrics look like. And then here, we'll then, we want to save the best model in an output directory. And then so to do that, we'll just write this line of code, trainer.say model, self.model directory. All right. Actually, so before I go to the publisher code, just wanted to see if anybody had any questions about what I've talked about with the training application itself.
I do see a couple of questions, but I think maybe they might be more related to architecture. So maybe I'll wait until we kind of get to that, get past the kind of the main application here.
Okay. Yeah, I think that what I'll do is like kind of cover the code in the demo, because I think we're sort of like, just to make sure we cover everything, and then maybe we can field some questions at the end. All right. So this is the Yelp review data publisher. And I will tell you, so this is like the bulk of the code that you're writing for the publisher. So this is actually, so for those of you who have tried to dabble in streaming solutions before, sure, like there's a lot more that you've had to write, but here there's like not much that you have to do. And if you run this like it on your machine, you'll kind of see like how quickly like you can kind of go from like just taking this code, and then you can kind of see how how it works. So with that, so we have the init method here. So what we need to do is pass in the topic, and then we're going to set up an interval because essentially we're going to be running this publisher forever. So you kind of have this interval kind of baked in to like have it kind of run this function, at kind of have a sleep set in, so that like, for example, like if you're calling a real-time API, you want to make sure you're not going to get throttled. And so, sleeping kind of ensures that that you're continually able to pull the API to get results that you need. And so all you have to do here is basically set up self.topic equals topic, and then the self.ensign equals ensign. So this is the ensign client. And then we'll set up self.interval equals interval. And then this is the line that kind of ensures that this publisher is going to be running forever. And you basically call this async io.getEventLoop.run until complete. And then you pass in the method that you want to keep running, which is the publish. And so if you look down here to the publish method, the first thing that we do is we'll write this line called await self.ensign.ensure topic exists, and pass in the topic name. And so this runs with this await keyword, you're running this asynchronously. And what this does is it's going to check to see if this topic exists. And if it doesn't, it'll create the topic. And then in order to sort of simulate this real-time streaming, what we're doing first is just reading the CSV file and create this pandas data frame. And then we will convert this data frame to a list of dictionary objects. And then we'll loop through this list. And so you have this like single record each time. And then we'll convert this record to an ensign event. And the way to do that is you have this so this is basically a dictionary object, and you can convert that to JSON, and then you specify the MIME type. So in this case, because it's a JSON, we're going to specify the MIME type, set MIME type equals application JSON, and we have this event, and then now we will publish this event. And so again, this has to run asynchronously. So we'll add this await again here, and pass in the topic name, pass in the event, and then we have this notion in the streaming concept. Like, so basically, the Ensign client is going to be communicating with the Ensign server, and we have to make sure that these like messages actually get published to the topic. And so on a successful communication, we'll get an ACK message. And so this on ACK equals print ACK is just what are you going to do like when you actually get an ACK message? So in this case, we're just going to print it so you can see that this event was committed to the topic. And then sometimes you can have issues like with publishing messages on a topic. So you might get a NACK message back. So in this case, also, we're just going to print any NACks that we receive on this stream. And then we'll set the sleep here with the interval. So that's pretty much most of like what you have to write for the publisher. So with the on the subscriber end, so this is going to be like our part of the application where we're going to generate predictions. And so here, again, it's going to be the same topic, right? Because the subscriber is listening in on that same topic in order to like receive these events. And we also have this model there as an additional parameter, because this is where we're going to pull out the model that we had stored at the end of the training application. And so in addition to initializing all these variables, we're also going to call this load model function, which does the following. So you're going to set up the tokenizer again. So it's going to be the same tokenizer that we use in the training application. And then here, everything looks the same, except that rather than like calling that pre-trained model, we're going to now use our customized model instead to generate predictions. And then we're going to create a pipeline object. So set the self.classifier to a pipeline object where we're going to do a sentiment analysis task. So the Dilbert model can do more than sentiment analysis. And in this case, we're using it specifically for sentiment analysis. And then we'll pass in the model and pass in the tokenizer. And then you can see here, in order to run the subscriber, everything looks the same as the publisher, except that we're going to call self.subscribe instead of self.publish. And what does subscribe do? So here we have, again, like the first line, where we're making sure that this topic actually exists, because if the topic doesn't exist, then you can't listen on this topic and generate predictions. So that's like your kind of like error handling here. And then as you receive an event through this topic, we're going to decode this event back to a dictionary. And then we will call this function self.generate predictions, which is up here. And so we're going to basically create a list of text. In this case, it's just going to be a single, it's going to be like the single review. And we're going to pull that text from this data. And we're going to append that text to this text list, which needs to be passed to the classifier. And so you call self.classifier and you pass in the text list, it'll then generate a prediction object. And what I'm doing here is basically this prediction object is going to have the prediction, which is going to be either negative or positive. And I convert the negatives to 0 and the positives to 1. And then I pull out the score, which is basically the confidence score that the model had in generating that prediction. And then in this example, I actually have the labels too, so you can kind of see what the model predicted and what the actual label was. And so then in the end, you can see this is the prediction, this is the prediction score, and then this was the actual label. And that's pretty much it for the subscriber. And so now let's take a look at a demo here. So All right, so I have here basically open 3 terminal windows. And if you take a look here, so I already did the training part because that takes some time. And so if you look at train models, you can see that there were 3 models that were created. And then if you look at the final model directory, that has all the model weights and configurations that are needed. And then the first thing we need to do is run the scoring, part of the application that does the predictions. And so to do that, we just have to run this Python Hugging Face score.py score. And then this is the one that's going to do the publishing. So this is called score data. And if you run this, and so you saw all the records that kind of got published and they got committed. And then you see these predictions that are happening. And so you can kind of see examples here. Like, for example, this review was left very frustrated. So really, like, the predictions is 0, which is a negative prediction. And that was a pretty high confidence score on that prediction. And then that was the label. And so there you go. This is sort of like your time, like kind of, streaming sentiment analysis. And I will go ahead and go back to the slide deck so we can kind of all right, yeah. All right, so back here. And so that kind of concludes like the part, and you have seen the demo. And so you can kind of see like how you can incrementally deliver insights. Again, like that was not that much data. You're able to see kind of how quickly, like, the model was able to generate predictions. And you can take the code that we have here, and all you have to do, like for your use case, start by just swapping out the data and the model and just make a few changes here and there. And you should be able to create your own LLM. And we would like to hear from you and see how it went, and share your work with us. And how you can do this is basically, if you can create a free Ensign account. So you have the link here to register and get your API keys. And then here's the repository, where we have the example. And then once you've kind of created, your own LLM, you can open up a pull request. And then if you are able to use streaming data source, and we have a data playground with a lot of examples of like how to actually ingest some of, publicly available real-time APIs, and can get a reward. And if you're interested, you can have your work featured on our website. And before we open up the floor for questions, just want to let you know that we have another webinar coming up at August 15th at noon, getting started with streaming data science, detecting earthquakes in real time. And we encourage you to register for that webinar. And also, as mentioned, we have the data playground. You can take this example that I did, use one of those examples and come up with your own LLM. And with that, I'll open up the floor for any questions that you have before we adjourn.
Thank you so much, Prima. It's kind of a little bit breathtaking, like how little code is actually required to do kind of a full end-to-end example. We do have a good number of questions. There's a couple of questions that I suspect are maybe a little outside of your area. So we have some questions about like regulatory compliance and GDPR. So I know that's not something that you focus on, but it's a great question. And if there are other folks in the on the call who are GDPR experts, definitely weigh in. I think that generally GDPR comes into play when it comes to training data and kind of making sure that people's private data isn't being used in a way that they would not want if they are part of the EU or one of the other areas that has regulations for data privacy, which is increasingly more places. We have a couple of questions about like kind of alternatives to Distilbert, and kind of like the issue of how many training parameters there are when it comes to an LLM. So kind of dealing with you know, when there are so many training parameters, do you have any tips about how to kind of manage like the massive search space that's sort of involved, you know, beyond kind of like the exhaustive search of just doing kind of like, like just doing a full hyperparameter search? Do you have any kind of tricks specifically related to LLMs or Distilbert where you would say maybe focus on certain parameters before you focus on others, anything like that?
So I would say, you know, the first thing, of course, is just use the defaults, right? I think that you might be surprised by like how much you get by just starting there. And I will say though that at some point, like when you have to start, start tuning in, I can't say that there's like anything, specifically in the training arguments, themselves that it kind of like all depends on like your use case. Like I think, based on like the kinds of results that you're seeing, you might need to like not, you might need to tune certain parameters over others. I would say like the one, where I had to kind of deploy, I did have to kind of first do the full training run and then do a hyperparameter search. And then the hyperparameter search kind of got us to that last mile of the of performance, that kind of helps solve the problem for our client.
I think that's like a great tip, which is, don't hyperparameter tune early, like do that later. Once you feel like there is something there in the model, the model is able to make some predictions. Maybe it's not great, but if you can kind of create a baseline where it's just doing anything helpful at all, then you know that investing in hyperparameter tuning is valuable. It's hard to kind of point to specific hyperparameters because every model is a little bit different. But I will say, I think that part of why people like Distilbert over some of the alternatives, like Roberta is another one that's like the Facebook version of BERT. But Distilbert, I think, is popular because it has like half of the number of parameters, half the number of training parameters as some of the other ones. So even though it does take, a little while to tune it, it's much more efficient than any of the other ones. And I think it serializes to smaller on disk than a lot of the other BERT variants that you can get on Hugging Face. So it is popular for that reason. It's very deployable. So let's see some other questions. How does this sentiment analysis tool, so the Distilbert sentiment analysis, how does that compare to other things I've heard of like TextBlob or Vader? Is it much better? Is it a little bit better? Is it worth it?
Well, I think it was worth it because that's the one that I tried, and we have a client that's actually very happy with the results that the model produced, and it really like wasn't as much, like one of the things with like using open source tools too is that because like there's been a lot of like community involvement in it. It was kind of interesting, amazing like how fairly straightforward it was to take this example and take the tutorial and kind of make some changes and tweak it for like the use case. Because my experience, like it's kind of interesting like how you use some closed source projects and maybe they're not quite as refined, and there's a lot more like things that you have to do before you can get stuff deployed. And so in my opinion, I was actually pretty pleased with using the Distilbert model from Hugging Face.
Fantastic. So let's see. Do you think that utilizing both Hugging Face LLMs along with PyEnsign to work on the logic of a chatbot would be more efficient in terms of the predictions? Would it be more efficient than using an OpenAI kind of like a proprietary alternative?
Well, I will say the nice thing about using, like this, Hugging Face and PyEnsign versus open AI is that the fact that you can customize it, right? Like, because how many of you have experienced with, chatbots where you're asking questions and it doesn't seem to understand, what you're asking, or just, all sorts of problems. But then here, if you kind of have this customizable application where you're feeding, you can record all those chats and see what you kind of figure out, what were the problems and how can we make this chatbot better? You have that flexibility to improve it over time. So in that sense, I would rather, use something, where you can customize it rather than something that's a black box. And even if it has done, really well, just because you just never know, when that black box model just does something really crazy and you can't do anything about it. And that's what you're stuck with.
Yep. Okay, let's see. So is there a JavaScript version? I know you're not a JavaScript programmer, although I know you know a lot of JavaScript programmers. Do you know if there's any way to use Hugging Face or Ensign if you are a JavaScript developer?
But I'm not aware of any JavaScript solutions, but I think potentially we might have a JavaScript version of Ensign in the future. And we will definitely post that out when it gets released.
Very cool. And it looks like there's maybe a few people who are responding in the chat with some suggestions of JavaScript implementations, maybe to swap out with Hugging Face. So let's see. We have a question about performance. So what are some of the features of PyEnsign that can help with performance of kind of training and streaming? And I think it's maybe a little bit like what you started to allude to earlier, where kind of training becomes more efficient because you don't have to hold a massive data frame in memory all at once in order to train the model. You can kind of incrementally train. And it means you can do it a lot cheaper and faster. And I think you do have some, do you remember what the metrics were on training kind of in batch mode versus streaming mode?
I don't have that off the top of my head, but there are, so what was kind of interesting is that I did kind of play around with an online learning model that seemingly, it was a different, experiment that I did with the, with the data that actually got results that were fairly close. It was probably not as good, as Hugging Face, but this was also my first pass at it, and it trained a lot faster. So in that case, you're actually just only training, incrementally training on one example at a time. But I would say, if the score was probably within the 5 to 10% range of within the 5 to 10% range of accuracy for something that did not require as much expensive hardware.
Excellent. So I think that might be kind of all the time we have for today. As Prima mentioned, if you're eager to kind of tinker on your own and see if you can create something, please stay tuned for the email that has kind of links to the playground and the repository that Prima is mentioning that has sort of this end-to-end example that she's been showing. You can clone it and probably swap out not very much to kind of get it operational for your own examples. And if you'd like to kind of share with us what you come up with, we would love to see that and also to support you. So if you get stuck on something, reach out. We're pretty easy to talk to. We're not gonna bully you or anything. We're all in this together. We're trying to figure out how to make data science kind of better ROI so that we all have jobs for a long time. So thank you all so much for coming. We hope that we'll see you at an upcoming webinar. I'm actually going to teach the next one. So if you want to see my approach to teaching, you know, I'm not sure how I'll compare to Prima. She's very good, but we would love to see you at the next one. I hope you can make it. Thank you again, everyone, for turning out today. It was wonderful to see you all.
Yep, thank you all. It was so great to see you.